Good morning, everyone. In this lecture, I am going to discuss about the regular grammar. So, grammar is a very important thing in theory of computation. We have talked about the classification of grammar in one of our previous lectures. So, you can check the playlist and you find out that the Chomsky hierarchy of the languages. So, there are four types of languages: type 0, type 1, type 2, and type 3. And every language has its own type of grammar. So, there are four types of grammars. Okay. So today we are going to discuss the regular grammar. Regular grammar is a very specific type of grammar which we use in compiler design or other places also. So first let's try to understand what is a regular grammar, how we can claim a given grammar as a regular grammar. Okay. So a regular grammar is a type of formal grammar that generates a specific class of language known as regular language. So you please can remember that regular grammar generates regular languages. It consists of a set of production rules that defines how a string in a language are formed. So this is the prime role of a grammar. It decides how the strings in the language will be generated. A grammar is a regular grammar if it is either a left linear, so I'm highlighting if it is a left linear or right linear. Okay. Or it is not and, right? So it is or. Either this or this should be satisfied in the production rules. So let me highlight again when I'm saying a grammar, the meaning, let's say if I'm saying G is a grammar, if I say G is a grammar, then G must have four tuples. So G must have a set of variables, that is non-terminals, set of terminals, set of, or you can say one starting symbol, and set of production rules P. So these four things, once we define, then we conclude, okay, grammar has been defined. So this V is a non-terminal, set of non-terminal, right? Set of non-terminals. T is, so I'm writing, let's say V here, T here. T is set of terminals. S is starting symbol of the grammar. And P is set of production rules. Okay. Set of production rule. Okay. So these four things are there. A regular grammar satisfies some of the property in this production rules. Generally, production rules look like the alpha implies beta kind of thing. Okay. So let's look at how we can say a grammar is a regular grammar. If a grammar is regular grammar, it just support two kind of production rules. Okay. So either it can be left linear or right linear. So in this alpha or beta, alpha must be a single non-terminal. Okay. Single non-terminal. And beta must follow some of the specific thing. Like if I say a terminal followed by a non-terminal or terminal, such kind of things if are there, then it is define the right linear property. If I say beta is something like variable followed by terminal or terminal, that defines the left linear property. So let's check it. Uh, there are linear grammars also, left linear grammar and right linear grammar also. So if a grammar is having left linearity or right linearity but not both, then we can say that grammar is regular. So let's understand what is linear grammar. In linear grammar, this is also a class of the grammar. It is the subset of context free grammar. So context-free grammar is powerful grammar as compared to the regular grammar. Linear grammar is one of the subset of the context-free grammar, but it is having more power than the regular grammar. So linear grammar we define somewhere in between context-free and the regular grammar. Okay. The production rules in the linear grammar looks like this. So left hand side there has to be a single non-terminal. Right hand side a terminal, then let's say non-terminal followed by a terminal. So in right hand side in the production rule there has to be single variable. V means variable, or you can say non-terminal. Okay, or it can generate only the sequence or the single terminal only. So this is a kind of linear grammar. Okay, left hand side of the production rule contains a single non-terminal, that please do remember, and right hand side of the production rule contains at most one non-terminal. So there can be 0 or 1 non-terminal. So if I take the example, of that grammar, you can say S derives A S B, or let's say null. This grammar we can say it is a linear grammar. Okay, right? So this is one of the example of linear grammar, but this is not regular. Okay, this is not regular. It is the subset of context free, right? Now left linear grammar. Left linear grammar having the production rule something like variable followed by terminal or only terminal sequence at right hand side. At left hand side there has to be only unique variable, single variable. Okay, so left hand side of the production rule contains a non-terminal, single non-terminal at left hand side, please do remember. And right hand side contains either a non-terminal followed by terminal sequence or only terminal sequence. Okay, so if I'm saying terminal sequence, you can put asterisk here if terminal sequence you are saying, or maybe single non-terminal you can write for that matter, right? So the example we can take like S drives S A. S is a variable or non-terminal, A is a terminal, S B or single A or single B. So this is an example of left linear grammar. Now there are right linear grammar also. So it is also a class of linear grammar. It is the subset, you can say. Each production or right linear grammar appears something like this. So a single variable can generate terminal sequence, asterisk means terminal sequence, followed by a variable. So terminal followed by a variable kind of sequence will be there, or only terminals, right? So the left hand side contains a single non-terminal, and right hand side terminal sequence followed by a non-terminal, or only terminal sequence. So the example has written here, S drives AS, where A is a terminal, S is a non-terminal, B is a terminal, S is a non-terminal, and so on. So this is a right linear grammar. And please do remember that every right linear grammar, there exists an equivalent left linear grammar, and vice versa. So for every left linear grammar, there exists an equivalent right linear grammar, right? So this is sufficient for this lecture. In the next class, we will discuss regular grammars in detail and solve few of the problems. So thank you everybody for connecting. See you in the next class.